All right. Well, good morning and happy Monday. And we are continuing on here, just working through kind of introducing our ability to kind of explore data, graphically, and also just kind of manipulating and tidying things up. I want to also get you to start thinking about forming groups for group projects. It's not going to be, I guess, probably by the end of this week. I want you to kind of get a sense. And so, for those of you who are here in person and for those of you who are watching the video recording online, I plan on having some designated time on Friday in the classroom to kind of talk to neighbors and mingle or whatever to, form groups. Those of you who are in person, you can take a look around and see like, all right, who are people who show up to class and stuff. But then certainly, if you're someone who's been watching the videos online, that's fine. But if you want to kind of try to meet some of your classmates in person, I want to encourage you to come to class on Friday, and I will have some designated time for you to kind of form some groups, okay? I also have this Google Sheet thing. Actually, I need to open that link I have to be logged into my UCLA account. So I think, let me copy this address over here. Okay, so on this sheet, I have just your names. I have the names from everybody's in the kind of the class, and then I have just a whole bunch of different kind of columns, and I think this is editable. For everybody who has a kind of a UCLA Gmail or UCLA Google account or whatever you call it, okay? And you can put in your contact information or whatever. Keep in mind this is available to everybody in the class, so don't put anything super private in there, okay? But it'll be things like what's your availability and are you somebody who prefers to meet in person or over Zoom or things like that. I put this column in here, like if you're okay with being a team leader. I know nobody like generally is like, some people might be like, yes, I want to be the team leader, but most people probably aren't like super eager about that. But I would say, in general, teams work a lot better if there is somebody who's designated to be the team leader, okay? But yeah, if you're okay with having that responsibility, that's ideal. And then, project interests, time commitments, any kind of additional notes. If you have a friend in the class, you could say, I'm already working with this person. So, and then you can reach out to one another. And then I'll also kind of create a thread on Campus Wire to help you guys try to find teammates, and then so you can start New York Times. So you can start filling out information on this thing, and then again on Friday we'll have some designated time for you to try to find some teammates. Okay, so that's I want you guys thinking about that. Okay, just because team projects are kind of unavoidable in life, like even after you graduate from school, when you work for a company, you'll probably be part of a team. It'll be rare when you're working all alone all the time. So, things always are better if you are working with teammates that you enjoy working with. Yes? Oh, you're right. I have it hidden. Okay. Yeah, I always forget. You got to click the little green check mark that says publish. Okay, so it should be there now. And that's that. Okay. I think most of you got your data camp homework turned in. I got a couple emails with people having problems with their accounts. So if you're still having problems with your account, come see me during office hours. But I think most of you got it. And if you didn't, then just turn it in late. You'll lose a couple points for being late, but you'll be fine. Okay. Homework 2 has been posted, so that's up, and that's that. Okay. Let's go ahead and take a look at more data wrangling examples with group by and summarize. So I introduced dplyr, part of the tidyverse, on Friday, and we showed things like, I don't know, select and filter, and just a little bit of group by and summarize. And we ran out of time for some of the later slides. So anyway, I wanted to kind of revisit group by and summarize, just because I do believe these are two very important functions, and really one of some of the most capable and powerful functions that we have available for exploring our data. Just because so much of our data, or so much of our exploratory analysis, effectually boils down to, here's kind of an overall trend I see. Does this trend still exist for this subgroup? And is it kind of consistent across the board? Or does it differ from one subgroup to another, right? So it's kind of just like, all right, if we see this overall relationship in the, just like anything, kind of like, do things differ for, one gender versus another? Do things differ for one age group for another? Is this trend going to be different for people in, this, segment of the economy, or this, these career choices or whatever? And a lot of it kind of boils down to, like, does this variable or phenomenon or something, is it different for this group versus that group, right? And so group by groups data according to one or more categorical variables, okay? And then summarize says, okay, for that group, try to calculate this value, right? Calculate earthquake. Did you guys get this? Okay. We'll keep that in mind. Okay. So what am I saying? All right. So summarize creates is going to create new columns based on summary statistics calculated from the data, and we often try to calculate these summary statistics or these values for different groups. Okay. And so together, when you combine them together, they can be very powerful tools as far as exploring our data. All right, so we will try exploring. Again, I'm going to use this Gapminder data. So again, the Gapminder data has information for a whole bunch of different countries, and things like life expectancy, population, and GDP per capita, along with and its information for that country in a particular year, in kind of 5-year increments or intervals. And again, just the caveat that some of this information is, I guess, I don't know what the right word is just kind of inferred or estimated based on other information, and countries and their borders have changed over time, even within the last 55 60 years or so, or 70 years. I guess 1952 is 73 years ago, and this covers a span of 55 years back to 2007, so it's already kind of dated. But borders and things have changed, so this is just kind of inferring some information back. But we'll take a look at using some of these functions. So I'm going to use summarize, and again, I'm accustomed to spelling summarize with an S because that's how I first learned it, but you can spell summarize with a Z and it will work fine. And depending on which textbook and online resource you use, they might use it with an S or a Z. And so just be prepared for seeing that kind of exchangeability or interchangeability. And also the pipe that I use the default pipe, which is a vertical line and a greater than sign. But a lot of kind of other materials will use %, greater than sign, %. These are just, again, you have kind of different symbols that do the same operation. So summarize effectively creates a new table with new columns based on whatever summary statistics we're calculating from the data. To use the summarize function, you have to specify the name of the new column that you want created, along with the formula that we're going to use to calculate that summary value. Maybe And so I'm going to calculate some summary values for life expectancy using some of the functions. So we have the function for mean. We're going to calculate standard deviation, median, quantiles, and n for the count. And I think, so mean and median, I think we're already familiar with those. Standard deviation gives a measure of the kind of the variability or spread if there's lots of kind of variation there. And then quantiles will give us boundaries for certain percentiles, like the 25th and 75th percentile. All of these things will include this option na.rm equals true, and that's to tell R that if you encounter a missing value, it's okay. That still just calculate the value based on the values we do have. All right, so using those formulas, I'm going to create new columns, and the new columns I've chosen these titles of average underscore expectancy, SD underscore expectancy, min underscore expectancy, median underscore expectancy, Q3 expectancy, max expectancy, and count, and things like that. And this is what I've done for quantile. So basically, I'm just saying mean of this variable, standard deviation of this variable, all of these things, all of them will have na.rm equals true to say ignore the missing values. For quantile, you have to put in what quantile you want. And so here in this case, I want the third quartile, which corresponds to the 75th percentile. But you could specify, if you want the 25th percentile or the 90th percentile or 99th percentile, you could put that in there, okay? And there we go. And so it has gone through and it has calculated these numbers for all 1,704 entries in our table. So our entire table has 1,704 entries, and it has calculated this. And so we have basically a new table, but just one row because we said do it for the entire thing. We didn't kind of group it by anything. Now, what I can do is I could say, you know what? I only want to find. I'm not interested in like the average life expectancy from 1952 to 2007 for the entire world, right? I guess the mean was around 59, median of around 60, okay? I might say, you know what? Let's look at some recent data. The most recent data we have is 2007, so I'm going to just filter our data to just the year 2007, and then I'm going to say, you know what? Let's just look at the Americas. So Americas will be North and South America, and the Caribbean, I think. And so this is what we have, and this is kind of the information. And so now I can say, all right, now calculate the exact same things, okay? But this time after doing the filter. So we start off with the original data. We apply the filter to just get the rows that we're interested in, and then we say, now calculate the summary value. So again, I just have one row because we have 25 countries represented, but we're just summarizing it. So for the year 2007, across all of the Americas, the average life expectancy was 73.6, median of 72.9, and that's what we have here. Okay. Now, just for comparison, I can say, all right, let's do the same thing, but let's look at 2002 instead. Okay, and so we could say, and sorry, the text size changed, but in 2002 for the Americas, the average life expectancy was 72.4. So going from 2002 to 2007, we saw a small increase from 72.4 to 73.6. The median used to be 72, and then it went up to 72.9. So, things looks like they moved in the right direction between 2002 and 2007 as far as looking at life expectancy. Oh, you know what? Let me pull up our view quiz answers before I forget, because I always seem to forget these things. Okay, first letter is D. D as in dog is your first view quiz answer, D. All right. Here I'm going to take our data, and I could do the same kind of thing. I could say, like, you know what? I want to calculate these summary values for the year 2007, and I want to calculate the same summary values for the year 2002. And I could kind of repeat this and say I want to do it for 1997 and 1992 and 1987 and 1982. And I can basically copy and paste my code multiple times and just change this year to different values. Okay? Now, rather than having to manually do that, I can just say, you know what? Group our data by year and then calculate the summary for each group. Okay? So it's kind of, again, I could do the filter for 2007 and then the filter for 2002, but instead it's going to be easier to just group by the year rather than filtering for each of those things. So here I'm still going to filter just to the Americas, but I'm going to say take the data and group it by year. And after grouping it by year, it doesn't look like we've really done anything to our data. Okay, but we do see this extra line here that says groups. We've got year and we've got 12 different groups formed. And so I take, that same chunk of summarize here, okay, and so basically I filtered to continent Americas, group by year, and then I say summarize. And then after I summarize, then I will arrange in descending order by year. And we could see, okay, it has calculated average expectancy, minimum, Q1, median. And so we could see, yeah, you know what? Is this the same thing I got when I filtered it to the year 2007? Okay, average expectancy of 73.6. Let's go back and check. Yeah, in 2007, indeed, 73.6, 60.9. That's what we have, 73.6, 60.9, okay? For 2002, we had what? 72.4, 58.1, and if I go back a couple slides, yeah, 72.4, 58.1. So it's the same kind of idea here of, all right, what if I filtered to just these rows and I calculate these summary statistics? Instead of having to manually do it for every single kind of year here, I could just say group by the year and then calculate these summary things. And when it does it, it basically splits up the data into each of those different groups. Okay, it splits it up into just the 2007 rows, and then splits it up into just the 2002 rows. And it calculates the summary statistics. Remember, each time we did these summary statistics, we just got one row, but it basically takes each of those rows and it pastes it together into one big table. And so on this slide, because I have all of this code taking up so much space, I just have it repeated so you can just kind of see all of these values, okay? So we can see in 2007, the average life expectancy for the Americas was 73.6. In 2002, it was 72.4. In 1997, it was 71.2, and so on and so forth. And we can see how these things have changed over time, right? And so this is really, I think, what makes the group by and summarize so powerful is that you can say, all right, these are the summary values I want to calculate. And rather than having to specifically, basically, filter to a specific set of rows, you can say, I want you to do that thing, but I want you to, basically create different groups based on this variable here. And it does it. And there you go. Okay. And then, furthermore, once you have kind of this output, you could visualize it too. So, I could say, all right, I want this, and I want this, and I want to visualize all of this stuff. So I can pipe these results into ggplot, okay? So I'm going to, so you're going to see a bunch of slides. Each of these slides, you're going to kind of see the code that I've written, and that's for your reference, so that if you wanted to reproduce a similar thing, but for a different set of data, you can use my code as a reference and a starting point. And then, but because the code takes up so much space, it you can't fit the entire plot. So I'll have the code and just the top couple inches of the plot. And then on the next slide, I'll just have the plot by itself, just because the plot by itself is also interesting here. So kind of like this. All right. So here, what I've done is I filtered just to the Americas continent, but I want to calculate for each year, I want to know the average life expectancy. Now, it's pretty much like this, except I'm not interested in all of these other things. I'm not interested in the mean and the first quartile and the third quartile. I'm just going to look at the average life expectancy. So that's what I have there. I guess I don't even need to have count, but that's what I have. And then imagine this table now. So this table is basically just these first two columns. And so we're going to map the year column to the x-axis and then the average expectancy to the y-axis. So when you do ggplot, you put in the name of the column that you created. So one column is year, and that's formed by the group by. And average expectancy, that's the name I gave this column. I'm going to put that on y. We're going to say geom line and geom point so that we get lines and points in our thing. Theme black and white puts the kind of very light gray lines on our thing. And this is our plot. And so we can see in 1952, our average life expectancy in the Americas was 50-something years, 53 years, maybe 52 years. And over time, it has gone up. And so in 2007, average life expectancy was around 77 years or something around there. Okay, so that's what we see. We can here again. So here I said let's filter it just for the Americas, but we might be interested in seeing, okay, well, how has average life expectancy changed over time, not just for the Americas continent, but for other continents, right? Asia, Europe, Africa, how has life expectancy changed for them? So with group by, you can group by multiple variables, okay? So I'm going to group by continent and year, okay? So, and we can say, all right, calculate average life expectancy, okay? Mean of life expectancy for each of these groups. And so we will basically have one group is going to be all of the countries in Africa in the year 1952. And then another group will be all of the countries in Africa in the year 1957, so on and so forth. The rows, you don't see, okay, here we go. We got more of the rows. And then we have all of the Americas in 1952, all the way through all of the Americas in 2007, okay? And then all of the countries in Asia in 1952 and all of the countries in Asia, and for each of these things. So we have a whole bunch of these different entries. We have a total of, 60 rows. And then the columns, we have our continent, year, average expectancy, okay? And then also count. I guess we have 52 countries in Africa, 25 countries in the Americas, 33 countries in Asia, and so on. Okay, does this kind of make sense? The idea of grouping by two categorical variables. Okay, and so now I'm going to take basically this table, and so picture the 4 columns that we have here: continent, year, average expectancy, and count. All right, and really only these 3 variables are the ones I map in our plot. I'm going to put year on the x-axis, average expectancy will go on the y-axis, and then I'm going to color the dots and the lines based on which continent. Okay, so we've got year on the x, average expectancy on the y, continent associated with the color of the dots and lines. Okay, so all I'm doing is I'm just piping our original data Gapminder into the group by, into the summarize. Okay, and that produces this. Okay, that's the code up to here, and then we're going to take this table and produce a graph. So I'm going to pipe that, basically that table, the output of the summarize function, into ggplot. And so with ggplot, we're going to say, okay, map year to the x, average expectancy to the y, continent to the color, draw lines and points. So we get the lines and the points all joined together. And so we have a question.
Just wondering, what does the count equals in? Like, what's the use of that?
It was unnecessary. I didn't have to do this, but sometimes I like to include a count just to make sure what I'm doing is what I'm expecting it to do. Okay, so like for the Americas in 2007, there are 25 countries, so I would expect my count to be 25. Sometimes when you do a group by and a summarize operation in ggplot, it ends up grouping more values than you want or not enough values than you want. So sometimes you end up with a count of 1 and you're like, oh, that's not what I wanted. I wanted to kind of group, these were the 10 rows that I wanted grouped together, okay? And then sometimes it ends up grouping like too many. You might end up with a count of like 200 or something, and you go, oh wait, that's too many rows, something went wrong. So even though I'm not actually graphing or making use of the count in the analysis part, almost every time I use a summarize function, I almost always include a count column just as kind of like my own check to make sure like it's doing what I'm expecting it to do. Okay. Whereas if you don't have it, you're just kind of like assuming you did it correctly, which maybe a lot of times you are, but sometimes like you've made a mistake, and count is often one of the early indicators to let you know that like, oh, something's not quite right. And then also another thing that could be a tip off is like if you see the count change dramatically from one year to another, then it's like, oh, maybe something's a little bit funny with my data. So this is more so just reassuring to me to see 52, 52, 52, and then 25, 25, 25, and something like that, okay? That's all. So yeah, I'm not making use of it, but it is, I guess, helpful for me to kind of let me know like it's doing what I expected it to do. Okay, and so this is the plot, and we see how average life expectancy has changed for each of these different continents, and how it has changed over time, and just kind of I guess depending which continent, different average life expectancies are seen in our data. Let me give you your second view quiz answer, which is the letter A as in apple. Okay. All right. So here we might want to know like we might want to like try to plot something. And so we could say, hey, you know what, again, let's filter down to the Americas. And you know what, let's plot every individual country. Okay, so I could say, so here there's no group by operation. I'm just saying let's take our Gapminder data, all of it, and let's just look at just the Americas. Let's look at every year from 1952 to 2007. Let's look at life expectancy, and then let's plot every country. Okay, and so there's 25 countries, and so this our plot looks a little wild. Okay, and it's really hard. It's really hard to tell what's going on because I don't know about you, but I have a hard time telling the difference between these colors here. Okay, like the color for like which line corresponds to Guatemala, which line corresponds to Haiti. I don't know. Okay, I have no idea. Which one is this line, right? And based on the color, it's going to be, Canada or Chile, and just kind of knowing the numbers. Like I know this one is going to be Canada and stuff, but again, it's hard to tell. It's basically, if you're using colors, I would say 7 is probably the limit that you want on like the number of colors you want in a thing, because once you get beyond that, now you start getting different shades that are really hard to tell. So I mean, you might get to 10 distinct colors, but you think about like a box of crayons, like the ones where you can simply identify, and it's usually like 8 colors in a crayon box, maybe 12, but now you're starting to deal with different kinds of shades. So anyway, this is the plot. This is a little bit tougher to do. So I'm going to just pick the 6 most populous countries in the Americas, just so that we can see it a little bit easier. So I'm going to just filter down to these 6. So I said, what were the 6 most populous countries in the Americas, at least in the most recent data on Wikipedia, and it said the United States, Brazil, Mexico, Colombia, Argentina, Canada. Those are the 6 most populous countries. So I put those into a vector. Okay, and I call that selected countries, and I guess this line becomes redundant, but I said take our data, filter it to the Americas, and then filter to country and selected countries. I guess this is redundant. I don't need to filter to Americas. If I'm going to just say select, just select these 6 countries anyway, but it's fine. Okay. And then, so now I do the same plot, okay, and it is filtered down to those 6 countries, and we can see this, and this is easier to read, okay? So we can see, we have Argentina and Brazil and Canada and Colombia and Mexico and the United States, okay? And so we have our 6 different countries appearing, and these colors are distinct enough for us to, easily identify. Them. One thing you can do even further is if you kind of want to emphasize the order here, right? So there's kind of like a natural, I guess, rainbowish order, right? Red, orange, yellow, green. So we went from like a reddish color to a yellow, orangish color to a green, blue, and I guess magenta, pink color, right? So there's kind of a natural transitioning of colors here. And you might want to have like double emphasize that with the order in which the colors appear here. And so here now, what I'm going to do is I'm going to reorder the countries by life expectancy. So at the top here, I'm going to put, the country with the greatest life expectancy in 2007 was Canada, with a life expectancy of 80.7. And so I'm going to have Canada show up at the top here in this color. And so the order, if we put them in order of life expectancy, the order of the countries goes Canada, United States, Mexico, Argentina, Colombia, Brazil. Okay? And so what I'm going to do here is I'm going to order it in that order, okay? And And so that's what I've done here. I said just filter, select country and life expectancy just for that year 2007, okay? And then we're going to arrange in descending order of life expectancy. So I have this, and now to extract this information, so this is, it says country is a factor here. In order to extract this column as a vector, we use this function pull, okay? So if you want to kind of extract a column from a table as a vector, the function you use is going to be pull. And so, I want it as a vector, and so that's what I'm going to do. So this code here, up through this line, is exactly the same as right here. And then I just basically added one more line, and that's going to be pull. And that's just to pull out that country column as a vector, and this is what I have here. And so here is the country order, and it's as a vector. And now I will create my plot. Same exact plot as before. This plot, the same thing, except as far as color goes, I'm going to put it in the order that I like. So this, that's done here. With color is factor on the country, and then the level we'll put in the order, our country order. And so this produces the same plot, but now the colors in this order appear the same as this table here. Okay, and so now in order of life expectancy, it's Canada, United States, Mexico, Argentina, Colombia, Brazil. The colors show up in this order, and they show up in this order on the table as well. Okay, which I don't know if it's aesthetically more pleasing than this one. It's not like, there's not like any new information, but there is kind of in this table maybe like a double emphasis on that ordering, right? And so again, the thing you want to kind of try to keep in mind is like, what is it that I'm trying to communicate to my audience? And if there's something that you really want to emphasize, it's okay, or it might be useful to like double emphasize that variable by kind of mapping multiple aesthetic attributes to that particular variable, okay? So you're not exactly getting any new or additional information, but your attention is drawn to that information in more than one way, okay? In more than just looking at the positioning, like the positioning and the color give us information about the greater life expectancy and lower life expectancy. So you're having multiple visual cues pointing to the same information, which can be used for emphasis. How many answers have I given you? 2. Okay, all right. Then I'll hold off on the third one just yet. Okay. What did I do? Okay. Sometimes you want to have information at like different levels. Okay. So here I have information on like the individual countries, right? I've got Canada, US, Mexico. I've got individual countries shown here. But perhaps, like if I go back over here, I have like information summarized on the continent. Okay. So I've got like Africa, Americas, Asia, and stuff like that, right? So I might, our data in our, we're looking at like the Americas, but I might want to include like the average for the Americas along with like our individual countries in here, okay? So here I'm going to say combining like summary, like continent level data along with country level data. So here I said combining individual country data with summary statistics, I guess at the continent level, can help contextualize like individual country performances versus compared to the regional average. So I want to show the individual countries and to have a line showing the average for the Americas. And so to do this, I have like information coming from like two different tables, okay? And can we put that into a plot? And yes, we can. It's just we have to kind of think about it and plan for it. So here, basically, I want this plot here, which, basically I have the command for this plot. But I also want to include basically information from another table, which is going to be created by taking our Gapminder data, filtering it just to the Americas, and I want to calculate the average expectancy for all 25 countries in the Americas. Okay, so this is going to be basically our summary values for just the Americas summary table. Okay, and so I want to include this. So this table here, Americas summary, is going to be an additional data source in my graph. Okay, and so here, basically this part up here is exactly the same as this plot. Okay, so this code right up here where I've said do the selected countries and all of this. So this code and up to this point, okay, are pretty much the same. And then I'm saying add one more line, and this line is for the average of all of the Americas. Okay, and so notice for here, I say my data is coming from somewhere else. This data is not coming from up here. This is like where I filtered to this and that. My data is not coming from there. My data is coming from a different table called Americas Summary. Okay, I still want to have year on the X and average expectancy on the Y. And to kind of distinguish this, I'm going to make the line extra thick. Line weight is 2, line width is 2. I'm going to color it black so it's distinct from everything else. And so now kind of the continent average for the Americas shows up here, and then we have the individual countries kind of displayed. And so we can see, some of these countries like Mexico and like Mexico here started below the continent average, but then improved to be above the continent average as far as life expectancy goes. Okay, and then others kind of stayed, above the continent average the whole time. Brazil is a little bit below continent average. Colombia started, far below, and then kind of reached and surpassed continent average for a little bit, but then kind of dropped back down. But this is what we see in our data. So we can kind of plot country level data along with kind of the continent level data in the same plot. You just need to create a separate table and data source for that. So that's another thing we can do. Okay, this is just something else kind of entirely moving away from just kind of like the Americas, where I just want to say, let's say we wanted to calculate the total population of the world. Okay, there's no value for total population of the world, but I can just take all of the individual country populations and add them all up. So I can say, like, for the year 2007, take all the population numbers, add them up for the entire country or entire world, and we get 6,251,000,000. Okay, that was in 2007. I think we're at 8 billion now, right? Is that right? What is the world population right now? 8.062 billion. Yeah. Okay, when did we pass 7 billion? Yeah, so 2007, 6.74. This estimates 6.24. Okay, well, it's a little bit off. 7 billion around 2010, and then 8 billion around 2022, 2023. Yeah. Okay. But fertility rates have dropped across the entire world, and so in order to kind of keep a population stable, basically I guess mothers are the rate of replacement is around 2.1 children per mother, and many countries have rates below that. Some are far below that, and so we will, I don't know when, but there will be a eventual population decrease. I don't know when it's going to peak, but that's another entire something else entirely. But anyway, but yeah. So in 2007, I guess 6 billion, 6 point something billion. We can say, hey, do it by year, not just. So again, anytime you do a filter, you can also think of like not just filter to this particular value, but what if we created groups on that variable instead, or something like that, especially if it's a categorical variable. And so we can say group by year, and then it says, all right, these were the populations. So 1952, our population of the world was 2.4 billion, and then it went to 3 point something, and then 4 billion, 5 billion, 6 billion, things like that. And we can create a plot. So this is the population of the world over time. It looks kind of almost linear here between 1952 and 2007. And you can say, all right, well, what if we grouped by continent, okay? And then we can also create a plot there. Is that right? Okay, so yeah, it's just Asia has the two most populous countries in the world, China and India, or India and China. And so this, their numbers are just way higher. And then Africa and the Americas populations have grown rapidly. Europe, from 1952 to 2007, the population increased only a little bit compared to, other, if you look at the other continents. Okay, Oceania, I think, is Australia, New Zealand. I don't know what other countries are included in Oceania in this data set, and so that one is just really small, and it's hard to see any kind of growth. Maybe a logarithmic plot would show kind of the rates of change a little bit better. That's another plot we could have used. Okay, that's it. Let me go ahead and give you your third and final view quiz answer for today, which is the letter B, B as in bear. All right, so my hope is that these plots and examples will help you as far as like when you start exploring your own data and things like that. You can kind of look at them as a reference and also kind of inspire you as far as creating, calculating summaries for different groups. As that, I think, is a big part of exploratory data analysis, is asking yourself, like, do these kinds of trends hold across all groups, or is it different for some groups? And when you notice things that are different for certain groups, it's worth delving into and saying, asking yourself, oh, what's going on here? Okay, so all part of exploratory data analysis. We will wrap things up here, and we'll see you guys on Wednesday.